Okay, so rather than just plot a bunch of points here to graph a polar equation in just a moment, I want to remind you of some things about the sine function, simply because we can use some patterns occasionally, patterns in symmetry occasionally to graph polar equations as opposed to just plotting a lot of different points. So for example, if you were to look at the sine function on the unit circle, the sine of, for example, pi over 3 is the same thing as the sine of 2 pi over 3, right? Because they both have the same y coordinate, and sine is the y coordinate in the unit circle. And similarly, here's 4 pi over 3, and here is 5 pi over 3. So the sine of 4 pi over 3 and the sine of 5 pi over 3 are the same as well, because they're both the same negative value. So, you know, if you go to plug in angles for these polar equations, you might use the fact that these two things are the same so you can see a symmetry when you're graphing. So, also, you know, if you look at pi over 6, then the sine of pi over 6 is the same thing as the sine of 5 pi over 6, and you can do the same thing on the bottom. You can do the same things with the pi over 4s, etc. You can also do similar things with cosine if you like. Okay, for example, in cosine, pi over 3 and 5 pi over 3 have the same cosine value because this is the x-coordinate now, so they both have the same x-coordinate. And 2 pi over 3 and 4 pi over 3 have the same cosine value because they're both negative the same value. So you can do similar things with this cosine function. Okay, so I want to graph this polar equation, and the first thing I would do is maybe start with a theta value of 0, and r would be 1 plus the sine of theta, but theta is 0. If you put that in your calculator, you know that sine of 0 is 0. You get 1 plus 0, which is 1. Okay, so you get, when theta is 0, r is 1, and so you get this point right here. And then you proceed as usual, you look at pi over 3. Now, we're dealing with the sine function here. Pi over 3 has the same sine value as, sorry, I meant pi over 6. Pi over 6 has the same sine value as 5 pi over 6, so we might as well look at 5 pi over 6 as well, and we'll see that we get the same thing for each of those. And in both cases here we get 1.5, so at pi over 6 we get 1.5, which is right here, and at 5 pi over 6 we also get 1.5, so you can see the symmetry here between those two. We could do pi over 3 and 2 pi over 3 have the same y coordinate also, so we'll do those two together. I'll just list them side by side since we're going to get the same value. Put it into your calculator, 1 plus the sine of pi over 3, and you get something like 1.9. So here we're going to be very close to 2, and here we're going to be very close to 2 as well. Let's look at pi over 2. There's no other angle that has the same sine value as pi over 2 within one revolution. So 1 plus the sine of pi over 2 is 2, so we're up here. Okay, now let's just go over here to pi. The sine of pi, actually, the sine of pi and the sine of 0 are both the same. So this is going to be a 1 again. So now we come back to a 1. And now let's look down here at 7 pi over 6. And that's going to be the same as 11 pi over 6. And that's 0.5. So each of those is going to be 0.5 in their respective directions. At 3 pi over 2, the sine value is negative 1. 1 plus negative 1 is 0. So we come back to this point here. So we get a shape that looks something like this. And all we did here was use some symmetry to graph it.